Hey there, Algebra 2A, welcome back. This is lesson 13, graphing linear equations. Our goals today are to graph linear equations using tables, finding the slope of a line, and then graphing linear equations using the slope and intercept, which we're going to use y equals mx plus b, slope-intercept form. Here we go. To graph a linear equation using a table, we are going to construct a table of values. We are going to plot the points, and then we're going to connect the points to form a line. And everything that we do with linear equations will always be a perfect straight line. So if it's not, that means that there was a mistake made somewhere along the way, and you should go back and check it. We'll start by constructing a table of values. A good place to start is picking your own x values from -2 to 2. These are going to work almost all the time just perfectly. Sometimes with fractions, you'll want to choose certain numbers, but -2 to 2 is a good set of numbers to use. And now we will start finding the output of each of these x values, the y, by using the function rule, 3x minus 2. Once we put each x value into the function rule, we get outputs of -8, -5, -2, 1, and 4. Next, we will plot the points. So we're going to write each of those input-outputs as an ordered pair. There's each input and output as an ordered pair. The last thing to do then is to start plotting and then connecting the dots to form the line. -2, 8, I'm going to go 2 to the left, 8 down, which is going to bring me off the screen just a touch. -1, -5 is going to bring me right here. 0, -2, 1, 1, and 2, 4. After we get them all, we're going to connect a line. We'll see how well I can do that. It's kind of hard with my setup, but there would be our linear equation more or less. And we'll connect it with arrows to show that those solutions do go beyond -2 to 2. We'll have infinite amounts of solutions for this particular linear equation. So there's a example how to graph using a table of values. To graph a line, we really only need 2 points to make it. And another way to graph linear equations, if they are in standard form, is by finding the x and y intercepts. If we think about a line, when a line crosses the y-axis, all the x-coordinates on the y-axis are 0. So wherever that line crosses, the x-coordinate is going to be 0. And wherever the line crosses the y-axis, wherever it crosses the x-axis, all y-coordinates are going to be 0. So you know that wherever that line crosses the x-axis, the y-coordinates are going to be 0. So to find the x and y intercepts, we can use those clues that x is going to be 0 when it crosses the y-axis, and y is going to be 0 when it crosses the x-axis. So we can make a little table, and in this table, we're going to be first substituting a 0 in for x, and that's going to create and find our y-intercept. And we're going to put a 0 in for y. That's going to calculate and find our x-intercept. So it's kind of like we have a clue about half of the ordered pair, and we can use that to find the other value. So we're going to find our y-intercept where we're going to put x is 0. We're going to find our x-intercept where we're going to put y is 0. So let's grab that equation and let's start putting 0 in to find the y-intercept and the x-intercept. So first, we are going to calculate the y-intercept. So wherever that line crosses this y-axis, that's where x is going to be equal to 0. So we look at the equation. Instead of x, we're going to put a 0 in and start to look at solving that out. We get 4 times 0 plus 5y equals 20. So anything times 0 is going to be 0. So we're basically just solving for y here. 5 times y equals 20. That means y has to equal 4. So our y-intercept when x is 0, y is 4. And then we can go and plot that out. So there's one of the points on my table, 0, 4. And there's my y-intercept. Next, we can find the x-intercept. To find the x-intercept, we'll put a 0 in for the y. So we're going to have 4 times x times 5 times 0 equals to 20. And again, the 5 times 0 is going to basically become 0. So we get 4 times something equals 20. That means that that's going to be a 5. And our x-intercept then is 5, 0. And when we have exactly 2 points, we can start to create the line between these 2 points. So there's going to be a second way we can use a table by finding the intercepts of your equation. Once we find both those intercepts, you can graph your line. All we need is 2 points to create the line. In our next learning target, we are going to look how we can calculate slope. Slope's definition is the ratio of vertical change compared to horizontal change. And sometimes that vertical change is called the rise, horizontal change is called the run. So it's a rate of change of how your line is traveling from point to point. To calculate our slope, we're going to take the y2 minus y1 over the x2 minus x1. So we're going to take the difference in the vertical coordinates, which are the y's, over the difference in the horizontal coordinates, which are the x's. And then anytime we have a fraction, we'll look to simplify as much as possible. In our first example, we're going to calculate the slope, and then we're going to decide whether it rises, falls, is horizontal, or is vertical. And on this first one, I did label the coordinates, so keep track that your x's are your first coordinates, y's are your second. X is your first, y is your second. Now we're ready to calculate the slope. So I took the y coordinate of 3, and I'm going to subtract the y coordinate of 5. So I chose y coordinate of 3 to be my y2, and then the 5 is going to be my y1. So there would be my difference in y coordinates, which is my rise. Now I'll take the difference in my x's. So I've got an x coordinate of 0, and I've got an x coordinate of 4. So I do 0 minus 4. Now notice the order. I went 3 minus 5. If I start with the 3, then I do have to start with the 0, because that comes from the same point as what I used in the numerator. Next, we'll do our subtraction. So in our numerator, we'll get 3 minus 5, which is negative 2. Denominator 0 minus 4, which is negative 4. And then we look to start to simplify. So 2/4, we know that that does have a common factor of 2, divide out of 2. But also we're dividing a negative by a negative. If you remember your integer rules, anytime we divide a negative by a negative, that equals a positive. And anytime we have a positive slope, that means that my graph is going to rise from left to right. So there would be our first slope calculation. In part B, I chose to use this negative 3, so negative 3 minus a negative 3, and then I go back, I use the 7 minus 0. Now we'll do our subtraction. In our numerator, we'll get 0, and our denominator will get 7. 0 over 7 is just going to equal 0. So here we have a 0 in my rise, so my vertical change. So that's going to mean that my line doesn't rise at all. It's going to be a horizontal line. So anytime we have a 0 slope, that's going to represent a horizontal relationship. In problem 3, we're going to take negative 2 minus 8 in our numerator, and then 3 minus 3 down in my denominator. So again, since I started with negative 2, I have to start with this y coordinate of 3. Well, now we got this situation, negative 10 divided by 0. Well, you actually can't divide by 0. That's going to give you an error, which means my line has got a slope that is undefined. It's only going to go vertical. It's not going to run at all, which we can't calculate that slope. It's undefined. And anytime we have a undefined slope, that's going to produce a vertical line. So this would be a slope that is vertical. And as you're just starting out with this, if you do graph out those 2 points, you'll see that they line up vertically, which also shows you that that's a vertical line, which is an undefined slope. And I'll walk you through the last one. We took 4 minus 3, which is our y coordinates. Then we took back to the coordinate that was with the 4, negative 5 minus 2, which you get 1 over negative 7. Now, since just one of my numbers in my fraction is negative, the overall value of this fraction is negative, which makes it so that it falls. So to recap, if we have a positive slope, it rises. A 0 slope, it's horizontal. Undefined, it's vertical. And then if it's a slope that's negative, you will see it fall from left to right. For visual learners, you may want to include a little picture of what each looks like. So we're always reading our graph left to right. So positive rises, horizontal, vertical, and then negative is going to go down to the right. Lastly, we'll take a look at how we can graph linear equations using slope-intercept form. So slope-intercept form gives us our equation in a form where we can see the slope, so how the points travel from point to point, and then we can also see the y-intercept. We can see where it crosses the y-axis. So in order to be in slope-intercept form, we have to have our y variable of our equation solved out. You will see a number in front of the x. That'll be your slope. So that's how we can see the pattern from point to point. And then we'll see a plus b or minus b, which will show us at which point or which part of the y-axis that the line is going to cross the y-axis. So we can see those when it's only in slope-intercept form. After we get the y-intercept, we'll start to look at graphing slope. So when you're moving from point to point using slope, positive slope, you're going to move up to the right or down to the left. Negative slope, you're going to move down right or up left. So we'll check a couple of things when we start graphing. We'll see if we're in slope-intercept form. And then second thing we'll do is we'll graph the y-intercept and then graph the slope to start to create the solutions of the equation. In part A, the first thing we recognize is the y is solved out. So now this is in slope-intercept form. I've got a number in front of the x, negative, which I'm going to assume that there's a 1 right there, negative 1. And then minus 3 means that my y-intercept is negative 3. So your b is negative 3, but actually the y-intercept is this point, 0, negative 3. So whatever b is, you can write it as an ordered pair like we did up here. 0, negative 3. Now we're ready to graph. So we'll take and graph where 0, negative 3 is, which is right there. Anytime we just have an integer with our slope, we can put it over 1 to see what the rise is, and then also see what the run is. And if we're dealing with a negative rise, we're not rising at all, we're actually going down. So this one would be going down for the rise, 1 over to the right for the run. So we got a negative slope, so we're going down right. Down right, we can graph a couple points this way. We'll graph a couple points going the alternate way. Once we get a few to start to produce that line, now we can start to graph our linear equation. So we graphed 4, 5, 6 solutions to the linear equation. We're going to draw those arrows to show that there are millions of solutions, infinite solutions to this. It just keeps on going. So we'll start by identifying this equation. This equation is not in slope-intercept form. The y is not solved out. So we got a little work to do ahead of time. We need to get the y on one side solved out and move every other aspect of the equation to the other side. First thing you always do is you get the x term moved over. So if I have a negative 5x, I'm going to use the inverse. I'm going to add 5x to the other side. And now we'll see what that looks like. And whenever we're starting to set up our slope-intercept equation, I just like to put the x term first to show that that's going to be my slope. Next, I've got to get the y solved out. So y is being times by 2. So we're going to divide everything by 2. And here's what that's going to look like. So once each term in my equation is divided by 2, I'm going to get y equals 5 halves x plus 5. From there, we'll take and find our slope, which is 5 halves. And we'll find our y-intercept, which is 5, which means that I am going to graph the point 0, 5 as my starting point. So that's the only solution that we can tell from the equation. So that's going to be our starting point. So I go up 1, 2, 3, 4, 5 right here, and I start to graph my slope. Now if I start to graph a rise of 5, so I rise up 1, 2, 3, 4, 5, 1, 2, I'm coming off the screen. Well, remember, if we do have a positive slope, you can go up to the right or down to the left. So I'm going to go down 1, 2, 3, 4, 5, back 2. There's a second solution. Down 1, 2, 3, 4, 5, back 2. There's another solution. So I can start to construct my line. And I apologize, it's not going to be perfectly straight, but there would be my solution to the equation. Negative 5x plus 2y equals 10. Transferred into slope-intercept form. It's the only way we can find that slope and y-intercept. Lastly, we'll look at a real-life situation. So slope is used a lot when you're talking about roof lines of a house, or you're looking at how streets are constructed so that water drains correctly. You have to have certain slopes to allow drainage and things. So we see slope in architecture, in construction quite a bit. If you don't have correct water flow when it's raining or when snow is melting, it can cause a lot of damage. So slope is important to use along with gravity to get water to run off to where it needs to go. Well, here we're looking at a ramp. So a ramp has a vertical change of 5.5 for every 10 inches of length. So vertical change, if you recall in our slope formula, vertical change is in our numerator. So that's going to be our vertical change. For every 10 inches of length, that's going to be over 10. Now we start to look at 5.5 over 10. I could rewrite that as 55 over 100. Multiply both of those by 10. Now we're at 55 over 100. We could simplify. They're both divisible by 5. So that would make 11/20. So the slope of 5.5 inches for every 10 inches in length would be 11/20. So other things that slopes use, usually when you're looking for water runoff, you want a 1/4 inch drop for every 12 inches so that you can get gravity to help you out and get that water to run wherever you need to go. Next time you're at a football field, you can look across the field. The middle of the field is going to be the highest point, so that any water that lands is going to hit the top of the crown and it's going to flow to the outside. So when you look at a football field from far away, it's actually not completely perfectly flat. It's definitely way higher in the middle, and then it flows, gets water to flow to the outsides. All right, that concludes lesson 13. So this was a 2-day lesson. You had half your notes on the first day, second half of your notes on the next day. You're ready to continue working on your Delta math assignment, and good luck.